two multiple choice questions about spring arrangements. So let's do it. This question says that springs P and Q are identical and each has a spring constant K. So K and K. Spring R has a spring constant 3K. So it's asking what is the increase in the overall length of the arrangement, of this arrangement, when a force W is applied as shown. So we know that spring constant is the rate between the force applied and the extension. So I'm looking for the extension, the overall length. So that way we have F over K. I know that my F is the weight W, but I don't know my K. So we need to work on this one. Springs P and Q are in parallel. So in this case, I'm going to add both K plus K. And is in series with R. So if it's in series, so we are going to do inverse of the sum of both of them. And this is my total extension, -1. All right, so now you guys can see this part here. So KT -1 is 2K -1 plus 3K -1. So I'm going to expand as a fraction. So 1 over KT is 1 over 2K plus 1 over 3K. So 1 over KT is equal, common term here is 6K, and 6K divided by 2K is 3, plus 6K divided by 3K is 2. So here we have 5 over 6K. I'm going to flip both. So KT is 6K over 5. Now I'm using this right here where I stopped because I didn't know how much was my total spring constant. So now I do. So this is W over 6K over 5. So this is the value of my K. I'm going to move here because I have some space. So this is W, and I flip the denominator. So it's 5 over 6K. Haha, and I find an answer. Here, 5W over 6K. The answer is A. Next question. I bet you don't need my help, but let's go. Two springs, one with a constant K1, 4 kilonewton per meter, and the other one with a spring constant 2 kilonewton per meter are connected in series. There is a load here, right? What is the total extension of the springs when supporting a load of 80 newtons? So I'm going to use the same strategy. So my extension is a force over the total spring constant. So I have the value of the force, but I don't have the value of the total spring constant, and we need to calculate that. So K1 is 4K is 4,000 Newton per meter, and K2 is 2,000 Newton per meter, given in the problem. So because both are in series, so my total spring constant is equal to 1 over K1 plus 1 over K2. So 1 over K, the total one is 1 over 4,000 plus 1 over 2,000. Okay, so 4,000 inverse plus 2,000 inverse equal inverse one more time. So this is the value of my total spring constant, 1333.33 Newton per meter. So back to the original formula here. This is 80 newtons divided by 1333.33. So let's see what we are going to get as an answer. So I kept my number here, right? So this is inverse times 80, 0.06 meter, which is 6 centimeters. Easy question for you. Bye, see you next time.